Hey everyone, I'm Richard. In this tutorial series, we're building a powerful character creator system where we'll be able to change our character's hair color, skin tone, swap armors and weapons, randomize our look, and save and load our creation. In this first video, we'll set up our project, build the complex character structure, and get all these animated sprites working together. I'll be using Godot version 4.5.1, which is the latest release to date. I highly recommend using the same version to ensure full compatibility with the features shown in these videos. You'll also need the assets we'll be using, so pause the video now and download the resource package linked in the description below. Once you're ready, run Godot and create a new project. You should then have a view similar to what we're seeing in the screen. Open the resources package you've just downloaded and drag the assets folder into the root of your project. You can see we've organized everything into different folders: fonts, sprite sheets, and SpriteFrames. And we also have a background texture that we'll be using in later videos. Now, head up to the project on the menu bar and click on Project Settings. First, let's set the resolution. Look under the Display category and then click on the Windows section. We're setting our viewport width to 1920 and the height to 1080. Set the mode to Maximize, Stretch mode to Canvas items, and the aspect to Expand. This will make sure our game always scales correctly to the screen size. Next, jump over to the Rendering category and then click on the Textures section. Change the default texture filter from Linear to Nearest. This is essential as it tells Godot to render our pixel art sprites with sharp, crisp edges. Now we can close the settings and start creating our main structure. On the left, select 2D Scene Root node and rename it Main. This node will be the one holding our player and our interactive interface. Notice the asterisk showing it's unsaved. Hit Ctrl S or Command S if you're on Mac and create a new folder called Main. Then save your main scene file inside it. Next, we add our character node. Inside Main, create a character body 2D and call it Player. You'll immediately see the warning that we need a collision shape. Every character body needs a collision area, so add a collision shape 2D as its first child. Now we fixed the previous warning but got another one. This new one saying that we need to define the shape itself. Go over to the inspector panel on the right and create a circle shape 2D. Finally, below the collision shape, add a node 2D and name it Skeleton. This is the key node that will hold all our layered visual parts of our character. Before adding the sprites, let's quickly check our assets. Inside the Sprite Sheets folder, you'll see the folders for each images we'll use for the animation. Now, inside the skeleton node, we need to create the visual layers. Let's start by adding an animated sprite 2D node. Then, duplicate this node 5 times so that we have a total of 6 animated sprites. Let's name them Body, Armor, Head, Hair, Eyes, and Weapon. Let's start the animation process by configuring our Eyes layer. Select the Eyes node and on the right, create new SpriteFrames. This creates a new resource to hold all our animations. We'll rename the default animation Idle Down. Click the Add Frames grid icon and select our Eyes Idle sprite sheet from our Assets Sprite Sheets folder. In this window, we get to see all the frames our sprite sheet holds. By default, Godot is dividing it by 4 rows and 4 columns. Having 4 rows is correct, since all our sprite sheets contain 1 row for each direction, which are down, left, right, and up. Our idle animation contains 20 frames, so let's change the horizontal value to 20. Now we can easily select the whole first row of frames and add them. Hit the play button here to see the animation. You can see it's a bit slowed down, so we'll adjust the FPS or frames per second to 10. Now we'll quickly create the remaining animations in the panel. Press Add New Animation. We'll name this one Idle Left and set its FPS also to 10 since we've decided that's a speed that looks good to us. Let's press the duplicate button 6 times while Idle Left is selected. This way we will create the remaining directions for Idle, Idle Right, and Idle Up, and the 4 directions for the run cycle: Run Down, Run Left, Run Right, and Run Up. Because we duplicated Idle Left, we avoided needing to set the FPS to 10 for all these new animations. The idle directions all use the same Eyes Idle sheet, so we can configure those quickly. For rundown, click Add Frames Grid and select the Eyes Run sprite sheet. You can see we have less frames for this animation, so this time, adjust the horizontal split to 8. Select the first row and add. We repeat the same selection process for run left, run right, and run up. This configuration is the most tedious part. Now that you know the technique, I've provided the 5 remaining pre-configured SpriteFrames files in the SpriteFrames folder that we added to the project before. This saves us from repeating this step dozens of times. So let's drag each one of them to their corresponding animated sprite node. Now, to test that everything is looking as it should, let's click on our body animated sprite. And now hold the Shift key and click on Weapon. This should have created a selection of all of the animated sprites. On the inspector, let's select the rundown animation and then click on Frame to change it manually. If we now press the up and down arrows over keyboard, we'll be able to increase and decrease the frame index of the current animation, giving us a little sneak peek of how the animation looks if all animated sprites were to play together at the same time. For a final visual touch, let's add a shadow. Create a Sprite 2D node inside the skeleton and assign the shadow texture, which we can also find inside our Sprite Sheets folder in Assets. As you can see, the shadow is currently being drawn in front of the feet. Let's toggle the visibility of the shadow sprite so that we can see it better. This is due to the drawing order. Since the shadow is the last node, it's drawn in front. We fixed this by dragging the shadow node to the very top of the skeleton list, and now it's correctly drawn behind everything else. It's time for our first test. Let's run the project. It will ask us which should be the scene to run, so we can just select our main scene. Nothing is visible, but if we look really closely, we can partially see our tiny character at the top left corner of the screen. This tells us that we need a camera that will center our view on the player. Close the debug window. Let's right-click on our player node and create a camera 2D node inside. Then let's hit play again. Now our character is centered, but it's still very tiny. Let's stop debugging and on the inspector, let's set our zoom to 15. Let's run the project again, and it should all be visible in Sharp. Now for the final piece of our setup, making the structure modular and playing the animation. Our player node holds many layers, and we want to manage this entirely complex character from a single template file. So let's start by creating a new folder inside main, called player. Now we select the player node in the main scene, and save branch as scene. Then we can save it in the player folder we've just created. This turns our player into a reusable character module, and all the inner nodes of it are now part of that player scene. If we ever need to make any change to the player, we just need to edit that one file. Let's open player scene so that we can attach our script. Be sure to have the root node of the player selected, and add a new script to it in the inspector panel, and save it as player. We will begin by defining the class of the script. Then we need to create references to each of our 6 visual layers. Let's start by creating the reference to a body sprite, using the onReady keyword so the assignment happens when the script is loaded and ready in the game. Notice we use the underscore prefix on the variable name. This is a gdscript convention used to mark these variables as private, meaning they're only intended for internal use within their own script. Then we added animated sprite 2D as a type hint for our variable. This isn't mandatory, but it's a huge help because it enables the Godot editor to give us helpful suggestions and autocompletion as we type. Lastly, we use the $sign when assigning the value, so we can provide the sprite's node path directly. Now let's do the same for the other 5 sprite layers. Define a variable called sprites as an array of animated sprites, which will serve as a list of all the layers for us to animate and customize later. Now we define our standard ready function. Notice the arrow void at the end? That simply means this function doesn't return any value. Inside we can assign our list of animated sprites to our sprites variable. Finally, we write our core animation function called playAnimation, which will simply loop through our list of animated sprites and tells each one of them to play the requested animation. To test, we update ready one last time to call this function and make the player idle with idle down. Time to hit play. We can now see our character is idling. All 6 layers are working together and our player scene is complete. In video 2, we dive into Godot's UI system to build our first customization panel for the hair color. Thanks for watching and see you in the next one.